Not today, but eventually, yes. We have to do some more stuff before we're ready to do the next activity, because you gotta be able to do measures of center and dispersion. So you have to talk about that. We will have another activity. Before I forget, next class though, quiz on 7.1 and 7.2. So expect that here. Alright, so let's do some in-class examples. Again, this would be similar to the kinds of things that you might be asked to do on your quiz. So it says, below are the percentages of 12 to 17-year-olds who post various types of personal information to their social media accounts according to a survey. Make a well-labeled bar graph to display the data. We're not actually I'm not going to build the bar graph, but any graph you make needs to have a title for the x-axis, a title on the y-axis, and a title for the chart. Okay? A lot of activities had histogram with no titles anywhere. Gotta have titles. Okay, that's part of the well-labeled piece. Okay? Every axis gets a title. Okay? I'm going to move past this because I think we can probably build a bar graph. Particularly here where the x-axis is just going to be like types of personal information, right? It's going to be words. Would it be appropriate to make a pie chart for this? What do you guys think? No, why not? Okay, yeah, so again, these are percentages of people who post.
There's a lot of overlap.
Right, yeah, many students or many individuals probably would be included in more than one category. Not really a good way to pie chart this, right? Good. In 2008-09 regular season, basketball player Dwayne Wade averaged 7.5 assists per game and 2.2 steals per game. The following pictogram displays this information. What's wrong with the graph above and how could it be improved?
Not clear.
Why do you say it's not clear?
It's like hard to tell which bars are which because they're overlapping and because it's hard to see through the basket.
Okay.
The scales.
The scale, what's wrong with the scale, Mia?
It's not numbered properly.
It's not numbered properly? I see 5 and 10 look like they're equally spaced.
It's not lined up with the lines.
Yeah.
Not lined up with the lines.
The number should.
Yeah, the
Quinn, what are...
The size of the picture is really just sized it up. That makes the graph harder to read.
Well, here's the issue, right? How much bigger is 7.5 than 2.2? About 3, right?
That's more than 3 times bigger.
Look at the basketball. Is the assist basketball way more than 3 times bigger? It's like 9 times bigger. That's the issue, that it's kind of misrepresenting how much more assists than steals the player averages, because the basketball size is, the area of that basketball is probably 9 times as big when the actual ratio of assist to turnover is like 50. If you had, yeah, or you just use a bar, right? Yeah, but yes, good. The bar graph below represents 2 different jobs and their earning potentials in US dollars per week. Please note the same information is used to display both graphs. What's misleading about graph 2 instead of graph 1?
Graph 2, it makes it look like there's a lot less, but it's really only an inclusion of less. It looks like
The range numbers are different as well.
What do you mean by the ranges are different, Nicole?
Like on the second one, it's like too broad of like a gap between the two. It's not as specific.
Okay, can you be more numeric? Because I look and I see that, you know, they're both going up by $200 increments. And there's the same number of increments between job A and job B on both graphs, but you're onto something here.
I can't really read the numbers from back here, so.
Oh, okay.
But, yeah.
Alex? Yeah, graph 2 doesn't start at $0. So if you look at graph 2, it looks like job B is 5 times more lucrative than job A, right? But really it's job B is really only twice as lucrative as job A, or less than half as, you know, you get what I'm saying? So again, you're just misrepresenting what's going on because you're monkeying with the axes because you're starting at 800 instead of starting at 0. Do you get what I'm saying? So again, bad job on graph 2. So here's a two-way table. Your task is to fill in the blanks with the numbers that go there. There's 2 feasible starting points to do this. Can someone tell me one of the 2 starting points by giving me the row title and column title that corresponds to the box where we can start this problem? Anthony.
Sophomores other.
Yeah. Because we know that this row, thank you, has 18 total people in it. We know 2 of the 3 spots, so we can find the third, right? What's that number there gotta be? 4. What's the other possible starting spot? Total for Android, right? We know there's 350 overall. We know the other 2, so we could find the third. So either of those are a reasonable starting point, and once you've got either of those going, it fills in pretty nicely after that, right? Is everybody okay? So let's fill it in. Right? We identified that this is, that's 4, right? Oh, not. This one is 4. So what's this have to be then? Mental math at 108. Okay. Hi, Lucas. What's this one got to be then? Okay. What's this one over here? Yeah. How about this one? Ooh, good mental math in. I love it. Give me one of the other 2. Oh, you're reading it off the key, aren't you? I see what you're doing now, Sam. You're impressing me for a minute. Now I caught you. 34 is this spot. I heard somebody say, good job.
Is it like 91?
91. Okay. So we filled it in, right? Could you do this again? It's not bad. You just find one of the places to start, and then from there, it just kind of builds off itself. You're always looking for a row where there's just like one piece of information missing, or a column where there's one piece of information missing. How many students total have Android phones? 85. What percentage of students are seniors that use iPhones? So, seniors who use iPhones, there's 91 of them.
26.
Out of 350. And then whatever, right? You guys can percentify it, I'm hoping, at this level. I can take that for granted, right? Yes, okay. What percentage of juniors use other phones? 11 out of 114. Yeah, who said it? Good job, guys. So you need juniors that do others out of the total number of juniors, right? We're only talking about juniors. Brooks?
Why would C be 91 out of 350? It's asking for seniors to use iPhones.
No, it says what percentage of students
Oh,
are seniors who use iPhones. So that's talking about everybody. In part D, what percentage of juniors, so we're only talking about juniors, use other. Do you see the distinction?
yeah.
It's a word thing. I know. You gotta be careful though. That's like gonna be the name of the game. All right. I'm not going to ask you guys to make the frequency chart here, but what I am going to show you how to do is use your calculator to sort this data so that if you had to make your own frequency chart, it's not so annoying. Everybody ready? If you have a calculator with you and you want to take it out to follow along, I encourage you to do so. If you're like, man, I wish I brought my calculator today, there's a stack on my desk that you can borrow to use while I'm doing it.
For sure.
All right. In this class, for the first half, almost everything you need is going to live under the Stat button. So you see the Stat button near the left-hand arrow? Let's press that. You need to enter raw data into your calculator to do statistics on it. You're going to use the Edit tab and the Edit command. So that's where we're at. I'm going to press Enter. This is going to open up the lists on your calculator. So the lists contain a bunch of entries. Each entry is an element. I'm going to start by, I have data already in my L1. I'm going to start by getting rid of that. I can delete individual entries by using the Delete button. I can just type over them if I want to, or if I want to clear the entire list, I'm going to move my cursor so that it's on the title L1, and then press the Clear button, not Delete, Clear, and then down, and it'll wipe the whole list for me. I'm going to enter the data from that table into L1. So I'm just going across my table, just entering each entry. Notice that I've done 8. There's 8 boxes in the first row, so I'm just going to kind of keep tabs on it. You can tell what number entry you're on because it says in parentheses. So the 9th entry should be the start of row 2 of my data. That looks good. Again, it's not going to tell me if I type a number in wrong, but at least I can keep track if I forget something. And again, you don't necessarily have to type in all the data verbatim. It doesn't matter so much. What we're doing right now is just kind of getting used to where the buttons are on our calculator, where the menus are, what the commands that we need to use do, what's the syntax for how to use them. So there I go. I got it all entered in. Everybody okay? Once I've entered my data, I'm going to exit out of here. So second, and the mode button will quit back to the main screen. What I'm going to do now is I'm going to look for the I want second and list, and I want to go to the OPS menu. That's short for ops or operations. So I'm going to pick option A, which says sort A. A is for ascending, so to start with the smallest value and list them out to the biggest. Anthony? Second, stat. That'll open the list menu. So I'm going to do list ascending on L1. So second and the number 1. And if I press enter, it says done. So if I go back and I pick L1 and press enter, it lists that same data set now ordered from smallest to biggest. So if I have to build a frequency graph, now I can see easily everything between like 65 and 68. I don't have to like search through the table, right? It's all just like in a row for me, so I can just scroll across with the left and right arrows and just count as I go, right? Pretty helpful, yes? So again, you do second list, scroll over to OPS, pick sort A for ascending, and then do sort A on list 1 to get the L1 to show up. You press second and the number 1, press enter, that sorts it. Then to look at it, you can either go back into the stat button under the edit command to look at it sorted, or you can just do second L1 and press enter, and it'll show you everything in the list that way also. Is everybody okay there? Just like hold it. So remind me again, what's a relative frequency chart? The difference between a frequency chart and a relative frequency chart? Does anybody remember? So the relative frequency, relative means percent, right?
Yeah.
So the relative frequency is just the percentage of that category out of the total.
Frequency is just like
The frequency is the count. Relative frequency is a percentage. Cumulative relative frequency is like a running percentage. So like if you had 10% for the first one and 11% for the second one, your cumulative relative frequency was 21%. So you're just like adding them as you go down. So at the end, your cumulative relative frequency for the last box should be 100%.
So when will that be used up? Like the cumulative frequency?
If it asks. Mostly to make like a cumulative relative frequency graph.
Are we doing that?
Yep. We did it in notes. You just forgot. Okay. I'm going to scoot on. This is the same question. I'm going to scoot past. Okay. So here is the same data set we just entered in, right? This question asks to find the average test grade for the class using the numbers above. You guys see that?
Yes.
Okay. What's the easiest way to do that?
Use your calculator.
Yeah, how are you going to use your calculator to do it?
Add them all up. You go to the.
Yeah, you do not have to add them all up.
Oh.
Yeah,
So
so
a stat,
You do the trick. You do the stat,
and then
you go bar one.
bar stats.
you do go stat over to calc and pick one var stats, that's correct.
List. You go bar.
L1, we have no frequency list for this, right?
Yeah.
Because we don't have, all these are just used one time. And we hit calculate, and the X bar is our mean. Gives us a whole bunch of other stuff, but the one we care about is the mean. So I press stat, I went over to calc, picked one var stats, made sure it was L1 was my list, the frequency can be blank, and I press enter. Is everybody cool?
The top one is the one that.
The top one is the mean, X bar is mean, yes. So 86.2 was our average. So far so good?
Or like if you're entering, we have to make it to three figures.
Correct. So 86.2. Alright. Here's the frequency chart that we would have made on the previous problem. it says find the associated mid-interval values. What am I doing here? Trying to write on it with this thing. Okay. Well, we'll write over here. What's the mid-interval value for the first data range? What's in the middle of 65 and 69?
67?
It's just 67, right? Everybody agree? If I go 2 up from 5, it's 7. If I go 2 up from 7, it's 9. 7's right in the middle, right? So 72, and then 77, and 80, 82, and then 87, and then 92, and then 97. Everybody feel good? Okay. Everyone needs to do this with me, because half or more of us did not get this question right on the activity. We're not able to correctly use your mid-interval values to approximate the average. So let's all do that now. So you can do it the good old-fashioned way. So I can do it on the calculator, typing things in. So the first thing I'm going to type in is 67 times the 1, because that 67 is used 1 time, plus 72 times the 1, because 72 is used 1 time, plus 77 times 3, because the 77 is used 3 times, and then 82 times 4, because the 82 is used 4 times, and then 87 times 5, because the 87 is used 5 times, plus 92 times 6, because the 92 is used 6 times, and then 97 times 4, because the 97 is used 4 times, and it's all out of 24 total scores. I press enter, I get this crappy looking fraction. How do I get that into a decimal? Deaths. Yeah, math deaths. So 86.3. Or 4, yes, thank you, Quinn. Why are they different? Why was the mean that I did it the first way 86.2, and now it's 86.4?
You're using estimation.
The mid-interval values are an approximation of the individual scores. Your associated mean from the mid-interval value will be an approximation of the actual mean. They will likely be different. Let me show you another way that we could do the mid-interval value mean that doesn't require me typing as much in. Okay? So if I do list, or I do stat, I do edit, I'm going to type my mid-interval values, say, into L2. I'm going to leave the other ones in L1 because I got to do this class again, well, not tomorrow, but soon, and just saves me the typing. So I'm just typing in my mid-interval values into L2 this time. Then remember I put them into L2. And then I'm going to put the frequencies into L3.
Thank you.
Everybody's okay? Yeah. I'm going to exit out of here, and I'm going to do the one variable stats, but this time I'm going to include a frequency list. So I'm going to do stat, over to calc, I'll pick one variable stats. My new list of mid-interval values I put in L2, and this list has frequencies attached to it. I put those into L3. If I hit calculate, look at my mean, it's the exact same thing I got last time, right? That 86.4. So again, you could do it either way, doesn't matter to me, right? Everybody happy? We know how to use mid-interval values to calculate a mean the correct way now?
Yes.
Okay, we don't add up the mid-interval values and divide by 5 or whatever. Don't do that. It's a lot of that. Okay. Example 8 is the same thing. I'm skipping it because we did it once already. I'm not going to do it a second time. Example 9 asks us to create a histogram with some data ranges. When you draw your histogram, what is Mr. Kulik going to be picky about?
Labels.
Titles for all the axes and for the graph. And the tick marks need to be equally spaced, right? Like your bars have to be equal widths. And you have to cover all the numbers. I saw some of us have like, when on your sleep things, I saw like 5 to 6.5 and then 7 to 8. It's like, well, those are the same width. And then where does 7.25 go? Like you didn't have all your numbers covered on your histogram, some of us. Ay. All right, let's do 11. So it wants us to make a dot plot from this data, and then we're going to describe the socks for it. Everybody cool? Guess what? Calculator can do the dot plot for us. Let's see how.
Wait, what does socks stand for again?
Shape, outlier, center, spread. Okay. So I'm going to start by going stat, edit, and I'm going to type this data into L4 now. That's bigger than what it is. That's not going to do it for me. All right, we have 40, 10, 320, 10. So again, feel free to kind of follow along as I'm doing this. Now, we're doing so many calculator things today that I don't blame you if, like, at the end of class, you're like, I still don't, that all blurred together. I'm not sure what to do or where things are or how to use these things. If at the end of class you feel that way, what can you do? Watch the video and follow along again. Like, do some of these problems that we didn't do together here, and compare them to the answer key. Remember, the answer key for all these problems is on note. All right, so I've entered all my data into L4. So what I'm going to do now, to get any kind of plot I want to make, second, y equals. I'm going to pick one of the plots. I'll pick plot 1. It's highlighted as on. And where's my option here? Oh, there's not a dot plot option here? I swear there used to be one. Yeah. No, that's a scatter. So I guess the best we can do is use the histogram one, and we'll just kind of make it work. Okay, so I'm going to do that. And then to graph this, I'm going to press zoom and stat.
Wait, don't you have to make the list to L4?
Oh, did I not do that? Ooh, thank you, Colby. Yeah.
Nice.
Yeah, good job on you, folks. All right. So I changed my list to L4 for sure, and then we'll do zoom stat.
Wow.
Yeah, I don't think that's what I wanted it to do. Look at that one. This one. No. Well, yeah. Let's try it. No. That's not what I want to do. I don't even know what that is. What kind of graph is that giving me? Interesting. Yeah, I lied. There's not a good dot plot. Dang it, I really thought that was a thing. So, what would you want to do for this then? No, if I have to make a dot plot.
Oh,
Make sure I
just have to draw.
I want to sort that data first, right?
No, you weren't.
Let's do that. That'll help at least a little bit, right?
Wait, what do you do again? Second step?
Second stat, ops, sort A.
That's actually. How we gone 17 years?
Do I know about this?
Okay.
I wouldn't be here without that song.
Now I need that.
Color violet. That's where I
I
was.
think I don't know. Yeah, I know.
Then I have 310. And I have 310 again. And I have 320. And then I have 320 again. And then I have 320 again. Oh my gosh, that's embarrassing.
I don't even have a problem.
That's more embarrassing.
No.
We'll let you know next time.
So there's our dot plot. Okay. Shape. What are the three options, the three possible answers for shape?
Left skew.
Left skew?
Right skew.
Right skew?
Symmetrical.
Symmetric. Very good. Which one is this?
That one is. No.
I agree. Symmetrical.
Told you.
It's just missing one. Yeah.
Right? Like the center is
Yeah.
what, roughly here?
Yeah.
That width and that width are about the same. Looks symmetrical to us, right? So the center looks like it's around 320. Do we see any outliers?
260.
260.
No.
I don't think it's enough.
No.
It's not, it's relatively, it's not really any further than like, you know,
Yeah.
like it's,
Calculated though?
there's a way to calculate it. We don't know how to do that yet though.
Yeah, we don't know.
And then the spread would be 380 minus 260 or 120. And this 120 is the range.
Wait, is this stuff gonna be on the quiz?
Yeah,
Is this stuff on the quiz?
sure. Describing a socks? Definitely. Everybody feel okay?
Yeah.
Blah, blah, blah. I don't want to do that. Stem plot.
Wait, is everything we're going over right now about the quiz?
Could be. I have a quiz description, I think, in here, yeah.
Oh, okay.
I have a quiz format down there. Stem plot.
Some plot.
The leaf is just the last digit of the number, right? So like, here I would have like 15, 16, 17, 18. Right? That's my back-to-back. Oh. Well, whatever. So it says make a stem plot for just the males. All right, well, let's do that then. So when I list my leaves for the 150s, what order do they have to be in?
These two groups.
Has to start small next to the stem and go get bigger. Do I use commas? No, no commas separate anything. We got that guy, we got that guy. I think this one is next. And then
Wait, what do those numbers represent?
just the last digit.
This is one. Make these so.
Yes. So you read this number as 151, right? And then so on and so forth, right? Is everybody okay? What does this still need? A key. What should the key say?
I don't know, I got that one wrong.
It should be in context. It should say 15/1 represents a male 14-year-old student. The height represents the height of, let's say a male 14-year-old student that is 151 centimeters tall. Right? Need context. 15/1 is 151, not good enough. Needs to have context. The direction, the lead-in that tells you what the data is about, that'll be what you need, right? So notice I just like read the blurb at the top, and then what that number means and the 151 means in context, right? Bless you, bless you. There's a lot of blessings.
I knew you were dragging it. You didn't actually mean it that many times.
All right.
You just wanted to say it.
Some percentiles.
What am I gonna say? What are you gonna say?
Zip it. All right. So it says find the percentile for the Minnesota Twins who won 166 games. So I'm going to locate 66, which is right here. Everybody agree?
Yeah.
So there are 1, 2, 3 teams that are better than them, right? Worse, sorry. That they are better than.
Yeah.
So they're going to be third out of 1, 2, there should be 30 MLB teams, I think. That sounds right. So that's 10%. You're to the 10th percentile. Not very good. How about the Washington Nationals that won 98 games? Well, that's them right there, right? How many teams are they higher than? 29. Can you ever have 100 percentile? Nope. It's not theoretically possible.
Can't do that.
What's up?
I'll do the math in my head on that.
Okay. Yeah.
I'm not gonna get it.
What if we have the Orioles who won 93 games? Well, again, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2.
Oh my gosh, gee,
Or you could have counted up from the other way. 1, 2, 3, 4, 5, 6, 7, 8. That are better than them, so you could have done like 30 minus 8. Everybody okay with doing that percentile calculation from a 7-leaf plot? Again, very easy if you know what it's asking you to do, right? That is the story of this class, this first semester, is all the stuff we're going to ask you to do is really an easy calculation. You have to know what the verbiage means to do it. But like, it's never going to be like unbelievably complicated and so confusing that like, oh my God, I don't know what to do. So for this one, it asks us to sketch the graph of the cumulative relative frequency. So we'd be plotting, these values. Everybody okay? Yes. Where this is like X and this is Y. You could write those as percentages too and not decimals. That would be fine. So everybody feel okay? Let's. Yep. So I can then use that to do some estimations, right? So I'm going to scoot over to the answer key where the graph is made because I don't really want to graph it right now. Is that okay with everybody?
Yes.
If I was going to ask you to use a graph to make some estimations, I would give you the graph. I wouldn't ask you to use your own. Blah, 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 blah. Okay, here we go. So if I want to estimate the percentile for 50,000, just taking the 50,000 up and transferring it over, and then estimating this to be like, that's probably 0.5 there. So it's like a little less than that. So he said like the 49th percentile. If I asked you like how much does the 80th percentile make? You start at the 80, you track over, you track down, and maybe you say it's like 54 or something, right? So if you have a percentile problem, like that's the gist of it. Is that okay? Yeah. Again, you'll see that. You should have seen that in the homework if you've started it already. So if I want the first quartile, what is the first quartile? 25%, right? So I just go back here, 25% looks like about this. I trace over and down, and it looks like it's, 44,000 or something. Again, it's going to be an estimate because you're reading it from a graph. If this had grid lines and stuff on it, we could do better, but with no grid lines, there's only so much you can do. Ideally, like a ruler would be nice, but whatever. I don't want to do that. That's the same problem. Oh, let's do this though. So it asks for the 5-number summary. What is the 5-number summary?
The minimum, maximum, Q1, Q3,
Yeah. So Q0, Q1, Q2, Q3, Q4, Q0 is the minimum, Q4 is the maximum, Q2 is the median. The calculator can do all of this for us, right? I would not want to do it by hand. I wouldn't encourage you to do it by hand. It stinks to do it by hand. I don't ever need to see you to do it by hand. Use your calculator to do it. So what I'm going to do is I'm going to type this data table into my calculator. So we'll do stat, edit. I'm going to use L5 and 6 to do this. So what am I going to use for my speed? Because I'm given a range of values. Mid-interval value. So 45 would be the first one, 55, and so on. Everybody's okay? If you're given ranged data, that's like in the table like this, and you're asked to do something like a calculation, there's nothing you can do without the raw data other than use a mid-interval value and make an approximation. Yes,
Make it better.
certainly. So I got it all in there, right? There's my table. Exit out of there, I'm gonna do stat, over to calc. One variable stats. I did that in L5, and my frequencies are in L6, so I have to include a frequency because the values are not unique. And then I'll press enter, and it tells me my minimum is 45, that's my Q0. Q0. 65 is my Q1, 65 is my median, 75 is my Q3, and 95 is my Q4 maximum. Is everybody okay there?
Wait, so you said next class will be this?
Yeah. Let's go is right. This is doing the same thing, and that's good enough.
It is on 7:0.
7.1 and 7.2.
That's it?
That's it.
So basically our homework.
I would look at these in-class examples also, I think would be a nice thing to look over. All right. Boy, I didn't leave myself any time to do 7.3, did I? That was on my to-do list for today. Let's start this and we'll just finish. We'll do 7.3 part 1, whatever we don't finish, and then part 2 next time. We have a lesson. Maybe we can do the other part of it after the quiz or something. We'll see how it goes. All right. So we're going to start with measures of center. We talked a little about center last time. It's describing like the middle of our data set. There are 3 main measures of center. Those are the 3 M's, the mean, median, and mode. So again, we talked about how to do the median. You arrange all your values in order from smallest to biggest. You find that if there's an odd number of entries, the median is just the middle value. There's an even number of entries, the median is the average of the 2 middle values. So if I have something like this, I'd sort it. Oftentimes a stem and leaf plot is an easy way to do that. I cross out one number from each end. I find that the middle 2 values are 20 and 25, and I take the average of those. Or, what would I really do? Type that data set into my calculator, do one variable stats, and read the median from my calculator. I'm not going to take the time to build a stem and leaf plot to count to the middle. Or take the time to like organize this from smallest to biggest and count my way to the middle. Yuckarooskies to both of those. I'm going to just type this stuff in my calculator and say one variable stat and take my answer and move on about my day. Yes, Anthony? Sure. The mean, also abbreviated with X bar, is like the average. You guys all know how to calculate a mean, I hope, right? Unless you're using mid-interval values to do it, which apparently we didn't know how to do, but we do now, right?
Yeah.
Okay, so just the sum of the observations divided by the total number of observations. So from a formula standpoint, oftentimes we'll use sigma notation to represent the formula for mean.
What notation?
So sigma, yeah, you heard me. So that E-looking thing is the capital Greek letter sigma. It means to like add up all these things. The I is like the index variable. So starting at entry number 1, all the way up to entry K. We're gonna add up the frequency of entry 1 times the value of entry 1, and then the frequency of entry 2 times the value of entry 2, all the way up to the frequency of entry K times the value of entry K. So F is the frequency, K is the number of times that it, or F is the frequency, X is the value of the entry, and then divided by the total number of entries. Okay, it's just the formula for the mean. That's all it's saying. Like, you know how to take the mean, right?
Yeah.
Yeah, and don't worry about the formula. It just means saying that, like, this is how we're gonna write the formula for the mean, like on an equation sheet. Do you have to do it that way? No! Cool. Of course. So if I want the mean for this same data set, I could do, you know, like, do this thing, right? Add them all up and divide by the total number. Or, what would I really do? When I did the one variable stats the first time to get the median, what else does it give me? The mean. So I just write it down from my calculator because I haven't done anything new. It's still going to be on the screen staring there right at me. Yes. Thanks, calculator.
So all you do is just add up.
All you do is type the entries into your calculator, do one variable stats, and read the X bar value. Right? I wouldn't actually add up anything by hand. It's just a recipe to make a mistake. To be quite honest with you.
Yeah.
If it has a frequency chart, how do I do a mean? Right, I have to do value times frequency plus value times frequency plus value times frequency. Or I do the same one variable stats in my calculator, but I must include a frequency list along with a values list, right? So I need two lists. One for the values, 0, 1, 2, 3, 4, 5, 6, and one for the frequencies, 5, 3, 3, 4, 2, 0, 3. Very cool? But again, like same thing. What if instead of specific values, we're given a range of values? What do I do then? Mid, interval, value. So I'm just going to take each of those ranges, compute the mid-interval value. That's going to be my list 1. The frequencies is my list 2. Do the one variable stats L1, L2, and go on about my business. Does everybody feel okay? Anything we're doing difficult? No, man, you just gotta and even the actual getting it into your calculator. The calculator will handle all the hard stuff. It just says what data do you need me to do this to? Just tell me what you need, and I will do it. Which is hey, thanks, calculator. So notice if you're not into watching the videos, you can take a look at this slideshow, and it'll show you the button sequencing that you can do. So stat, edit, type the stuff in, blah, 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 type in your frequencies, do this, talk you through exactly what we did earlier. One bar stats, L1, L2, and there's your output. Blah, 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 blah. That's it. Everybody's okay?
Yes.
What's the mode? We have the mean, that's the average. The median, that's the middle value. What's the mode? Yeah, Anthony.
Isn't it the highest?
The most frequently occurring value, yeah. What's the highest frequency?
Yeah, he was on the same page.
I mean, you didn't say what you meant, but I knew what he meant. What happens if you have a tie for first place?
You lose.
No, man, they're both the most.
It's bimodal.
Yeah, bimodal. You have two of
Do
them.
you remember that?
No big deal.
No, you don't. No, you don't.
What happens? What happens if you have a range of values listed instead of individual values. Then instead of having a mode, like a single value that occurs the most time, you have a modal class, the range that appears the most time.
Yes, it did.
So in other words, to find the mode, all you gotta do is count. Right? You're just looking at frequencies.
It's pretty easy.
All right. So we have these three measures of center. How do I know which one to use?
Depends on what's being asked.
Median is better for skewed distributions. Okay? Because it's affected less by outliers. Mean, best for symmetric distributions because it is much more affected by outliers. Mode, you'd use for non-quantitative data. So if we were asked everybody their favorite color, we can't really take the mean of colors or the median of colors, but I could look at the most frequent favorite color as the mode. Everybody's okay with that? This will be a test question. Like I'll give you a distribution and ask you to draw in where the mean, median, mode are approximately. Where's the mode going to be on the distribution? Let's say we have this distribution. Where's the mode at?
Oh,
The highest.
Okay. That's the most frequently occurring, right? This is like the number of things. Where's the median going to be? To the left or to the right? To the right, how much?
A little teeny.
A little bit. Okay. Where's the mean going to be? Further right than that.
It's pulled out.
Because it's going to be pulled in the direction of the skew.
Wait, but I feel like it really depends on the data because there could only be like 1 point out there, right? Technically.
Let's go, I got an 82.
Oh, what is that? I guess it's.
It'll pull the mean more than the median. Right? Think about what happens to your test average if you have 90, 92, 97, 94, and you get a 54.
It goes down a lot.
Yeah, but your median score is still a 90, right? But it's the 54 crushes your average. Get it?
Yeah.
Okay.
It was so cheap. I was so
That's it. We did it. That's the first half of 7-3. We'll do the other half next time. The homework. The homework for Sunday. 7-1 and 7-2. Next class. Quiz. On 7-1 and 7-2.
Put it away like a good.
I know I had it.
Everyone's fair break.
That's all right.
Yeah, I got all there.
There you go.
That's good idea. We need some,
Yeah, this hours.
Yeah, their time work.
Really?
I know.
I'm excited.
My skin looks pretty good.
Yes, you got it.
You don't.
I don't think it's a